Hello, hi. Welcome to the new video. Here we are going to discuss about Docker networking, where we are going to discuss what exactly the need of Docker networking and how the networking works inside the Docker and what are the main network types in Docker and overlay networks also and advanced network types also and some practical example and some best practices need to be followed. Okay. So yeah, without further ado, let's enter into the video. First of all, Docker networking. Basically, whenever let's discuss why do containers need networking? Okay, so let's say containers need to communicate with each other like microservices. Then we need a networking connection between them and applications need to reach the internet or some external database at the time it is useful. Let's say users need to access a containerized web application, they need network access. Let's say if different containers might need to isolated or shared network access. In that case, it is helpful. Okay, and if you see some real use case, so, yeah, let's say if we have a web application container that need to talk with database container. In that case, here the network, mm, this need to be database need to be reachable to the web application, right? So in that case, it will be helpful. Let's say if the database container need to be talk with the cache container, and here basically Docker networking makes a container talk to each other, and it is reachable to the outside world safely and efficiently. That is the use of networking here. Okay. Moving to the next, let us see how the Docker networking works. Okay, so here is the host machine where your PC, let's consider, and basically it contains a virtual network which is Docker 0. Okay, it is a virtual uh, network bridge, and where it connects to a container key which is running in Docker, and also it will connect to your container B which is in Docker. Okay, and if you see here, the your host IP address which is something like 192 dot 16.0.2 like that, and the container IP address is 172.17.02, and another container IP address is 172.17.03. Okay, but with the help of this bridge, virtual network bridge, you are able to communicate with this to this. Okay, and you are able to reach out to this. Okay, with the help of this particular Docker Zero bridge. Okay, so these are the like the key pointers you wanted to consider. Let me scroll down. Yeah, if you see here, there are some key points which made very simple. Virtual networks is just like your Wi-Fi networks, but software created inside Docker. Okay, how the Wi-Fi is it, the virtual network also same. Okay, and but it is like a software which is created in within the Docker and automatic IP address where the Docker assigns your IP addresses automatically. You don't need to be worried about that. And network isolation, which contains in different networks. That means one network cannot be seen in another network. That is the isolation. And port mapping, where we are going to connect container ports to host port, like port forwarding on your router. It is works the same. Okay, 1 minute. Yeah, sorry. And also DNS resolution. Let's say if we have mapped a domain name system, containers can find each other by name, not only the port. Okay, there are two ways. Okay, and just a small point, just Think of it like apartments in a building. I mean, non-technical example if you consider. Each has an address, some shared hallways, others are private. Okay, it is the same like that. Like a DNS resolution, port mapping, network isolation, automatic IP addresses, virtual networks. It is like same as uh, apartment apartments in a building. Okay, and moving to the next. Yeah, here is the main network types. Okay, basically Docker provides you three basic network modes for different needs. The first one was bridge network, and the second one was let's discuss one by one later. First one was bridge network. So here it is like a default and most common network. If you talk about what exactly the bridge network, it is like a virtual network bridge inside your host. Okay, and the use case was single host applications. It will be helpful. Let's say if you have a multi-tier application, let's say web app plus database on the same machine. In that case, that need to be communicated each other, right? So in that case, bridge network will be helpful. That is all about bridge network. And coming to the second network, which is host network, where we can also say, let's say, if direct host access is required, in that case, we can opt for host network. And what exactly it was? Containers uses host network directly. Okay, so here it is a virtual network bridge inside your host, but here it is directly. There is no virtual network in between. Okay, and it is useful for high performance and monitoring tools. Let's say if we are if you wanted to perform the system monitoring or network scans, then this will be helpful. That is all about host network. And coming to the third one, which is non-network, that means non-network. So here it is a complete isolation and no network access setup. Uh, and the use case was, let's say, if we have a batch processing or security critical tasks or some data processing jobs. In that case, it will be helpful. That is all about non-network. Okay, and yeah, there is just a small command just to create a containers with a different networks. This was the command. What you see here, this was the command. Okay, Docker, sorry, Docker run hyphen network was the like argument you need to pass, and none was the network name, and this was the image name alpine. Okay, it will basically create a null network. Likewise, we do have a sorry, it was not showing properly. Let me scroll. Yeah, if you use this command, basically it will create a host network. Okay, so hyphen network bridge and nginx. For nginx it will create a bridge network, and for nginx again host network. Let's say if you wanted to try to reach out from host network which is running nginx container to a bridge network again nginx container, you cannot able to ping that. Why? Because the network bridge was different. Okay, likewise you can create a different networks. Okay, and move to the next. Sorry. Yeah, it is also one of the type which is overlay network. So basically, let's say if containers running across multiple machines, uh, Docker Swarm and Kubernetes, in that case, it will be helpful. Okay, overlay networks. So basically, uh, multi-host communication need to be done in this particular overlay network. Overlay networks create a virtual network that spans across multiple Docker hosts. This is the one. web container, and this is the API container, and this is the DB container. Let's say if you wanted to have a network connection among all these hosts. Okay, in this case, this multi-host, overlay network is implemented and used there. Okay, and here all containers can communicate as if on the same network. Okay, to and fro will be happened there. Okay, and if you see here, there is a uh, just for your understanding when to use overlay networks. Let's say if we are using a Docker Swarm for multi-node container orchestration, we can use overlay network. And also for Kubernetes, let's say container clusters across multi-servers and microservices. Let's say services distributed across the different missions, different host missions, load balancing, spreading containers across multiple hosts for performance purpose. In that case, also we can opt for overlay networks. And this is the command to create a overlay network. Let me, sorry, this is the command basically. Docker network create hyphen driver overlay and my overlay. Okay, that is the overlay. Uh, I mean, basically, you can give any your name, okay, overlay network name. This is the but this is the complete command to create the overlay network. How the command earlier I have shown here to create a networks within your Docker, and this is also same. Okay, and moving to the next advanced network types. Basically, if you see here, sorry for the disturbance. Yeah. Basically, in advanced network types, and there is a special networking for containers that need direct network access. So these are those special networking. Okay, one is MJC PLAN, Macvlan LAN network, and IPVLAN. Okay, which is basically MAC is direct physical uh, address. Okay, so direct physical network access. It, containers gets its own MAC address. That is the one point. And benefits in this MAC VLAN network was it appears as physical device as on network. Okay, how the physical device looks, it uh, appears the same. And if you see the like use case, let's say if we have a legacy applications or network application, in that case we can go with this. And let's say if we need to have a network monitoring, so Macvlan network was the better choice there. And in IP VLAN network, let's say if we have a shared MAC or multiple IP addresses, in this case, IP VLAN network will be the preferred one. And what exactly this IP VLAN network was? Let's say if we have a multiple IP addresses in the same MAC, in that case, uh, I mean, that is exactly the IP VLAN. And the benefits of IP VLAN was less network overhead than MAC VLAN. Okay, basically, network overheads will be reduced. And the use case was, let's say if we have the MAC limit exists, in that case, we can opt for IP VLAN network. And if you see the example, cloud environments with MAC restrictions, in that case, IP VLAN was the best suitable option. Um, yeah, here is just a small comparison, uh, small network comparison, like a bridge, where virtual network inside a host. Okay, and MAC VLAN is like directed to physical network, And host is basically use hosts network stack. And when to use advanced networks, these are the some pointers need to be considered whenever you are going for advanced networks. Let's say Macvlan. So when containers need to appear as physical devices, in that case we need to go for Macvlan. IPVLAN. Let's say when you need direct network access, but MAC addresses are limiting. Okay, direct network access is required, but MAC addresses are limited. In that case, we can opt for IPVLAN. And also, there are two more pointers need to be considered uh, whenever choosing the network. We need to consider carefully, like more complex to troubleshoot and manage if you miss to consider carefully. And most of the project, bridge and overlay networks use usually sufficient. Okay, so that is the like important networks. And here is some practical examples and the best practices for networks. So some network commands. Let's say if you wanted to list all the networks, we need to use this particular command: Docker space network space ls. Let's say if you wanted to create a custom network, Docker network create my app network. My app network was the network name basically. Okay. And let's say if you wanted to run containers on the same network. Okay. So here we need to give command like Docker run hyphen network my app network, like whatever the network you have, or else existing network. And here the application, I mean, hyphen name and web nginx. Okay, basically you are giving this container name as well, and nginx was the image name. Okay, and here also the same, like you are using the same network. Okay, which you see here, this and this network was same. Okay, so now for Nginx container and MySQL container, which is a web application and a DB container, is able to communicate each other, reachable. Okay, and all containers now talk to each other, like these two containers. Web can reach to DB. That's was the point here explained. And here there are some best practices if you see, and some security tips also. The best practices was we can use custom networks inside your default bridge. That is the one. And use a containers meaningful names for domain naming system. Okay. So while mapping, you need to give a like decent name, like web DB, like that. And we need to isolate your different applications in separate network. Use the environment variable for configurations. That is also one best practice. Document your network topology. And coming to the security tips, don't expose unnecessary ports and to host. Okay, that is the one best security practice you need to follow. Use internet networks for sensitive services. So don't go with the host network. So use the like internal. Okay, and regularly update your container images. Okay, for patch management purpose. Monitor network traffic. Okay, for monitoring and troubleshooting purpose. Use secret management for passwords for securely handling the data and the credentials. Okay, and coming to the final real-time example, like combining all together, we can say. Now, let's say if we have a web application, okay. So in this particular web application, we need to uh, only expose front end to the end users. That means to the host, we can say. Okay. So only front end we need to expose to the host, and backend which will be maintained internally only. That means within the Docker network, and database also maintained internally only. Okay. So only front end is accessible from the outside world. Backend and database are protected within the network. Okay. So yeah, I think this is the thing. I think we covered and some good pointers and understood good about Docker networking, how exactly it works with the example also. Okay. Yeah, I think we are good to conclude. Stay tuned for more videos. Thank you.